ASD versus strength design or LRFD.
Okay, I
As
think
many of you are
it's
aware,
recording it.
allowable stress design, like we mentioned, was the older methodology for evaluating anchor
Mm,
systems. This involved evaluating an
nice.
anchor and testing it to failure to create an ultimate load, and then applying an industry safety factor of anywhere between 2 to 8, depending on the anchor, to create an allowable load. It's important to note with this methodology that there was no actual understanding of what your controlling failure mode was. So the safety factor
I'm
was
making
used
a
to
podcast of
account
this.
for any possible failure of the steel element, the load transfer mechanism, or the concrete. Now, as the shift in the IBC went to strength design, you can now see on the right where we're now getting a more analytical approach into the evaluation of anchor systems. With strength design, we are going to be looking at tension and shear, looking again at the steel, the concrete, and the load transfer mechanism failure to create what we call nominal capacities. We then take the minimum of those to create a design strength and then compare against our factored load. So now you, the designer, can see if, for instance, my steel is the controlling failure mode, is it possible to use a higher strength steel element or maybe possibly a different anchor load transfer mechanism to create a higher capacity? In the bottom, you will see that ASD is currently still appropriate for anchorage into masonry. However, like we did say on the model building code landscape slide, IBC does formally recognize strength design or LRFD as the main design criteria for anchoring to concrete. Now, looking at these different design methodologies, some of you in the poll did say you are using simplified design tables to evaluate your anchors under the allowable stress design provisions. So as you can see on the right, you will take your table, look at your anchor diameter, your embedment depth, and then go into your tables and see what is my allowable load in tension and in shear. This is going to represent the capacity of a single anchor. So then you will then, of course, have to go into your load adjustment factors to reduce the capacity of these systems. One limitation of these is that these are going to be pre-calculated values at set embedment depths. So linear interpolation can be used, however, it's not going to be the most accurate, and there is going to be some limited flexibility on using these tables. Following suit with the ASD tables, we now have LRFD, load and resistance factor design simplified tables. So instead of going through the full calculations from ACI 318, there are now pre-calculated values located in these tables. Again, you will go in, say what is my anchor diameter, effective embedment depth, concrete compressive strength, and get your design capacity in tension and in shear. You'll then be able to go use your load adjustment factors to reduce the capacity based on your anchor layout. Here, there is a big thing you want to be aware of. Linear interpolation is not going to be permitted with these tables because there is not a direct linear relationship. So you cannot go in and interpolate between effective embedment or concrete compressive strength. These tables will also not take into consideration things such as moments, eccentricity, standoff, or anchor reinforcement. So you can see these tables, although they're using the LRFD methodology, there's still going to be some limitation. But the main question is, if I have any of those moments, anchor reinforcement, how do I account for that? And that is where you're going to see a hand calculation with the strength design or ACI 318 anchoring to concrete provisions. So you, the designer, will take a copy of ACI 318. You will use the product's ICC ES evaluation report and go through the design check. So kind of following through the image on the left, you will look at tension, calculate your nominal capacity. The minimum of those will then become your design strength by using a phi factor, which will then be compared to your factored tension load to determine if the anchor system does meet the criteria. You'll follow similarly for shear, and then if you have tension and shear, you will perform the interaction check to determine what the resultant force would be. Now, as many of you know, when using a hand calculation, this is very time consuming. So as you can see on the far right, an example of this, calculating these variables will take some time. And if you make an error, say you get to the design check, you follow through and your interaction fails, now you might have to start all over again with a hand calculation, thus taking even more time to evaluate an anchor system. And that is where Hilti Profis Anchor is going to be a great resource for you. The software is going to go through, take the ACI 318 anchoring to concrete provisions, pull in the relevant data from a product's ICC ESR, and perform the analysis real time for you. So you, the designer, will be able to go in, select an anchor, input your design provisions, enter your spacing, edge distance, your factored service loads, and then see real time, what is my utilization? And does the anchor system meet the design criteria? Therefore, providing you a quicker analysis that's going to be more laid out. And so with that, I'd like to turn the presentation now over to my colleague, Morgan Young. He's going to walk through two design examples for you, one a static load application and one a seismic load application, to show you how to use the software so that way you, the designer, can be more comfortable with using it. All right, Morgan.
Hello everyone, my name is Morgan Young. Thank you so much for your attention today. We're going to get into two examples here within Hilti's Profis Anchor software. So to start off, this is what our design is going to look like on the first example. It is going to be a relatively simple static design. We're going to use lightweight concrete. We're going to be trying to find a solution with a mechanical anchor and with the loads shown here on the screen. So with that, let's get into the software.
The one that we don't have.
The one that we don't have. Tell them.
We don't have it.
We don't have it. Please change your ways. Remember the majority said.
Okay, so you should be seeing our software now load up here on the screen.
So this is not the one we have.
I'm going to take us to the default screen when you open up Profis Anchor. So when you open up Profis Anchor, you're going to see this new project screen here, and you'll see the region and the design standard. It will default to where you are currently located. So for us, we're located in Plano, Texas. We're going to be under the United States region using the ACI anchoring to concrete provisions basis for design. So I'm going to start a new concrete project. So with this new concrete project, this is what your default screen is going to look like when you're using Profis Anchor. I want to point you towards 4 key boxes that are both going to be on the left and right of the screen. These 4 key boxes are going to allow you to make a lot of your inputs and view a lot of your outputs as you're using the software. So I'm going to move my mouse over to the side of the screen where we're going to look at the anchor filter. So for this example, we need to find a mechanical anchor solution. So we're going to filter out our adhesive. So I'm going to select on mechanicals and filter out Hilti's anchor portfolio for mechanicals. So this is a great place where if you need a stainless steel element or if you need a different element to use or a different class of anchor, this is where you can filter those items out and use those for your design. So I'm going to hide this so we can see the anchor portfolio, and we can always bring this back up if we need to. I'm going to select here a quick bolt TZ, which is a mechanical anchor that we're going to use for cracked concrete, and the holes in my base plate are going to be a 5/8 diameter, so I'm going to start out with the default embedment that we have. So after you filtered out your anchor, and if you've decided that you want to start with an anchor or select an anchor, that's great. You select that, and now I'm going to point you over to the right side of the screen where we see the results pane. So follow my mouse with me to the results side, and here's where you're going to find the live output of the software that is doing the calculations. So here you're going to see design method. It's not currently checked right now. And then you'll see technical data and then utilization. So Brian talked about what are these design provisions. These are ACI 318 anchoring to concrete provisions. You're going to see that load on the design method side. And then you're going to see the technical data, which is that ICC evaluation service report that Brian touched on early in the presentation. So it's taking the provisions from ACI and then the technical data in the ICC evaluation service report, and then it's calculating that utilization. You may be asking, what is the utilization? That's great. Hold that thought. We're going to get into that later in the presentation. And the very last box that I want to move my mouse to and show you is the messages box. So as you're inputting your geometries into the software model, you're going to possibly see messages appear here. This is going to happen if you have a geometry constraint to where the anchor cannot be installed at that location, or your concrete thickness, whatever the case may be, you will see the error message here on this side of the screen. Now that we've touched on these 4 key boxes, I want to walk you through the top section of the software. We're going to cover 5 tabs, starting on the base material tab. So this design is going to use cracked concrete. And you might remember it was 3,500 PSI, and we were going to use lightweight concrete. So immediately here, this is the default section. I'm going to change our compressive strength to 3,500 PSI. You're going to note that we don't see it. That's okay. We're going to go down to custom, and we're going to just enter our compressive strength. So you edit the field, and then you hit enter, and it's going to update that now for the calculation. Moving over, you're going to see lightweight concrete. You'll notice that lightweight concrete is grayed out. That means I can't select it. Why is that? The reason for this is because Profis Anchor defaults to ACI 318-2008, which we did not input the lightweight concrete function. So in order to use lightweight concrete, we need to use a more current version of ACI. So we're going to use ACI 318-14 by going to the Loads tab and making this change. So moving back to the base material tab, you'll see lightweight concrete is now selectable. And I will select lightweight concrete. You will see the lambda value activate. And now it will be orange. So anytime you select something in the software, it's going to highlight that button orange. So keep that in mind. We do get several calls on how to activate this lightweight concrete option. So the second portion that I'm going to take you to in the base materials tab is the edges function. The edge function allows you to input the fixed edges in your design, and the way that these arrows are laid out will be a standard XY axis. So in order to emulate this and show you, I'm going to zoom out of the model, and I'm going to rotate using the right-click function on my mouse, and I'm going to orient my design to show you where our fixed edges are going to be. And you'll see there that positive Y reflects positive Y, and so on and so forth. So I'm going to bring this back to an isometric for the remainder of this model. We're going to have our temperature function, which is relevant to our adhesives. And then we're going to have our installation condition. It will be a hammer drilled hole in dry concrete. And again, this is the default that's going to be here. To the far right of the screen, we're going to see supplementary reinforcement. Again, this is the default for supplementary reinforcement. We're going to assume no supplementary reinforcement. And then if you want to change condition A to shear or condition A in tension, as well as the bar size, you can. So what's going to happen when you activate that? The software is going to pull in the appropriate psi factors and phi factors in ACI and use those in the calculation. On the very far right of the screen, moving my mouse again, you're going to see anchor reinforcement. You will not be able to select anchor reinforcement because we're in the post-installed portfolio. There is a cast-in-place option that will allow you to do cast-in-place calculations when you can use this anchor reinforcement. So if you have the reinforcement in cast-in-place design, that can negate concrete breakout in both shear and tension, you can select those options and the software will work accordingly. Okay, so this is the base material tab. I'm going to move over now to the anchor plate tab. Here you can select pre-selected geometries on the physical plate, or you can make your own. We're going to leave it here as the default square. We're going to change our base plate thickness to 5/8 of an inch. I'm going to hit enter, and now you'll see the model has reflected it. Next to the plate thickness option, you're going to see standoff. It defaults to no standoff. The next design that we're going to do is going to have standoff, and I'm going to touch on what those options do when you activate them in the software. Moving to the anchor layout tab. This is where we modify what our anchor layout is going to be. We're going to use the default 4-bolt symmetrical base plate pattern, or symmetrical anchor pattern, excuse me. And we could change it if we wanted to, and sometimes we have the option to do asymmetric. So not all designs will be symmetrical, so we can activate the asymmetric option, and what I'm going to do is show you how it changes when I make the change. So here I've made an asymmetrical change, and now the software is going to calculate the anchor group and calculations capacities accordingly. For this model, I'm going to deactivate it and stick with what we had for the design. We have a reduced edge distance function should we be using an adhesive and want to get close to the edge. And then these remaining two functions are for cast in place. That is why they're grayed out. So there are provisions in ACI 318 for cast in place scenarios when we can have torqued and untorqued anchors and evaluate them accordingly. We can also change the washer thickness and the plate, the washer thickness or the plate thickness, and that's going to have an effect on what our calculation capacity is going to be for these cast in place options. So we're going to move through that since we're doing post install. Moving to the Profiles tab, this is where you're going to change your profiles that are showing up in the design model. You'll see in the center of the design that there is already a default S-shape 3 by 5 by 7 in the design here. We're going to use no profile for this example, but in the latter, we will use a more common profile. Should you want to change the eccentricity of the application, you can. We're assuming a concentric load on this first one, so I want to show you if you did have an eccentric load condition and not a concentric, you could make that change by simply inputting the direction in which the eccentricity is occurring. And the last tab we're going to look at before we begin modeling on the software screen is going to be the Loads tab. Very important. We came to this tab when we made the first change. We're just verifying that we are using ACI 318.14 and that we are going to do static design. And you'll note this is not activated on the seismic design. We're going to do that later here in the second example. Okay, so we're done with these 5 tabs. Now let's focus on our model in the center of the screen. I'm going to zoom in for clarity. So the very first change that we always want to make is going to be the anchor spacing. And the reason for this is the anchor spacing drives the edges, drives the edge distance. So if we change an edge distance before we change an anchor spacing, when we change that anchor spacing, it's going to change the edge on us. So we want to be efficient when we're using the software and make these changes accordingly. So I'll go ahead and click on the anchor spacing dimensions first, and I will hit the value and hit enter. So here I'm going to change our anchor spacing to 6 inches, both symmetrical. And now the second thing I'm going to change is my base plate spacing. So this base plate is going to be 10 inches by 10 inches. So I'm going to make these changes here as well. I'm going to zoom in some more. And now I'm going to change the fixed edge dimensions. We're going to have a 4-inch fixed edge as well as an 8-inch fixed edge. Again, zooming in for clarity. And now I'm going to change the concrete member thickness. So you'll note that it's very simple to go ahead and make these changes on the model. You just simply double click on the geometry and you'll be able to make that change. Now for load inputs, we have 2 ways that we can do this. We can do this either on the physical load itself by clicking on the parameter and inputting our load. So we've got a 2,000 pound tension load. Or we could input it down here at this table. It does not matter where we input it. We're going to input our shear load in the negative Y direction and kind of zoom out, double check our geometries. Everything looks good. This is what we wanted to use. And we're okay. So now you may have noticed on the far right, moving my mouse over to track with me here, is we've seen this results section update. It's been updating with the tension capacity, the shear capacity, and the tension and shear combination, as well as showing us the embedment depth. So I'm going to open up these tension and shear capacities just a little bit more, because earlier in the presentation Brian talked about load and resistance factor design, where we're looking at these 6 different failure modes and evaluating each one, finding which one controls, and then taking a look at our tension and shear combination by which which load combination, or excuse me, which failure mode is controlling. Okay, so here we have a nice layout, and it's live. Every time we make a change in loads, it's live, and it's showing us that factored load provided by the design capacity that our design is going to see. So once
I don't think the
you've
plate-
looked at this
No,
information and you
it's
want to know a
only
little bit more about it, we can
Can the
run
fl-
a
can the
design
plate fail
report
in
so we can
punch-
check the calcs.
punching?
So the way we do this is we
Punching
went up to the top of the
shear
screen
with
next
the
to the wrench and we
column.
click on the design report.
It could
And
be two
here,
pin, right?
this is where we can
But no, that's
input
impossible.
all of
You know what I mean?
our
Yeah.
parameters for the
Finger.
project,
You
make a
punch
nice
through
professional
The plate.
example.
Hmm.
We're going to save this report. Everything
they're
looks
right here.
good.
Steel.
When I hit OK, we're
bolt
going to
tension,
have this
concrete
design
breakout,
example
pull
load,
out.
run the calculation so we can walk through what
Hey.
this looks like.
What the hell?
So the very first page that you're going to see, I'm going to zoom in for clarity, is going to be our inputs. So our inputs here, we selected the quick bolt TZ, we selected the embedment depth, the diameter. It's telling us which version of ACI 318 anchoring to concrete provisions we're using. It's giving us the ICC evaluation service report for that product that we selected. It tells us, hey, we're using cracked lightweight concrete with a compressive strength of 3,500 PSI, and that we're not taking into consideration supplementary reinforcement. Great, that's what we had. Now we're looking at the model. Our model looks good. It looks just like what we wanted. And now we're going to walk through the design report, specifically the calculations. When you go to the second page, you're going to see the anchor reactions that the software is taking into consideration. This is great because if you have questions on what it's considering, especially when you have eccentric conditions, this can be very cumbersome to figure out what loads are going on, are reacting on what anchors. So the way we do this is we can zoom in, we can take a look, everything looks good. I want to point your attention to the tension load section 3 here, where we see our steel strength pull out and concrete breakout. So earlier, before I ran the calculation, I said, here is what our utilization is. What is our utilization? This is a nice, clear picture of what that utilization is. Focus on the load column. This is our highest factored tension load if we're looking at steel strength, or our factored tension load of the anchor group. And then we see our capacity of the anchor system. So we have the load and then the capacity of the anchor system. And then that utilization is simply a percentage of the ratio that's been dividing the load against the capacity. So this is the summary. And we can see here, based on this summary, that our concrete breakout is going to control. So because of that, I want to now move towards the concrete breakout calculation and show you just what we're looking at with concrete breakout. So for concrete breakout in tension, or for the concrete breakout or any of these failure modes, it's going to be laid out in a very nice, simple format. And it's telling you, here are the calculations that we're using. It's telling you ACI 318.14, so it's using the latest version of anchoring concrete provisions, as well as the variables that it's taking into account, and then the calculations that the software has ran, and it's telling you what that is, and then the results. So at the very bottom of your screen, you're going to see the results option. You'll see the nominal concrete breakout capacity. You're going to see the phi factor that's been used, so that strength reduction factor that Brian talked about. You're going to see what the software is using. And then you're going to see the phi NCBG. That is going to be our design strength capacity for our concrete breakout, as well as our factored load at the end. So everything is nice and laid out and showing you and being transparent of what the software is taking into consideration so you can check it. Likewise, I'm going to zoom in again for shear. So for shear, we're doing the same thing. We're looking at the 3 failure modes respective to shear, and we're taking a look at those factored loads against those design strength capacities in shear at those failure modes. And again, we have a concrete breakout failure as our controlling failure mode. So I'm going to bring us to the concrete edge failure mode here. Again, the same thing. We're having all these calculations now respected to shear. So chapter 17, section 5, where these concrete breakout and shear calculation provisions are. It's telling you what equation and where it comes from. It tells you the variables that it's using, as well as the calculation. So a big part when we're doing concrete breakout calculations with anchor groups is going to be that projected area. So we want to verify that we have calculated by hand ourselves against what the software has calculated for these projected areas, as well as what the software is taking into consideration for our nominal breakout strengths. Again, you're seeing these phi factors, you're seeing where this information comes from. And the last thing that I really want to focus on is going to be the tension and shear load utilization. So what is happening? What is the software doing? So the code allows us two ways to calculate tension and shear from a combination standpoint. And this is that trilinear method where we're taking the factored load against our design capacity in tension, and then it's going to add the factored load in shear against the design capacity in shear that's controlling. So both controlling failure modes in tension and shear. Add those together and make sure it's less than or equal to 1.2. The other way is the same sort of ratio, but now to the power of 5/3, where we're making sure that that is going to be less than 1.0. The software is going to check both. Typically, the parabolic, or the one calculation going to 5/3, is going to be used because it's usually more favorable for the design standpoint. And here you can see that we are okay on the tension and shear utilization at 45%. So zooming out, the remainder of the report is going to be some installation data, such as installation torque, what to expect with the product that you selected, as well as geometries of the anchor plate that was used.
Why is engineering so hard?
So now I'm going to exit out of the report, and we're going to go back to the presentation, and we're going to take a look at
There's so many different things.
what our second design is going to be. So hopefully that was
So you're gonna stay
informative.
with IES
You
through
were
the whole
able
year
to sort of understand what I was doing, why I was doing it. Now I know a lot of you are
You're
here
doing
and you're
December,
going,
right?
okay, it doesn't apply to me. We're out in the West Coast. We're doing seismic design. Great. This is where we're
If
going
you
to
wanna
get
go to do a
into your
master's
section here, a little bit more
you want
complicated design. So we have
from them,
cracked
then you
concrete,
have
no
to
lightweight
stay
this
with them,
time. We're going to
kind of.
use a different profile,
Unless you went,
and we're going to have seismic
because
moment.
what if you
We're
want
going
to
to
go to
have a
school for
seismic
masters-
shear
for
load,
masters?
Yeah, I went to
and we're
university.
going to have it in the direction of an edge.
I'm pretty sure you haven't talked to them about that. Like, what if you want to go somewhere else? How are you
So
supposed to
moving
work
back
for
to
that?
the software, I'm going to
if-
start a new concrete project.
I'm pretty sure you thought of that,
So
right?
again, we see our
Mhm.
default
Like-
screen.
Once you go to your masters, then
Now I'm
more
going to move through
scholarships?
this one just a
Sure.
little bit quicker because there are some extra things I want to touch on that we
that's a good
didn't
idea.
with the static design. So I'm going to hover back over to my anchor
Move away
filter,
from them for a little
and
bit.
now I
Get
want to use an
other
adhesive, so I'm going to
experience.
filter out mechanicals, and then I
Oh.
want that to go away,
You're not trying to start in the spring,
so I
are you?
can now bring up
No,
our
I
anchor
didn't apply.
product
I
line.
need to wait 1 year.
You should get some good
So I'm going to
experience.
start
Go
with a
apply-
threaded rod and an
apply
HY200, and
for
we'll
a
see where to
semester
go from
long
there. So
paid internship
we're going to
somewhere
now
else.
go back to the base material
Oh, wait,
tab,
can
and we're
you-
going to set our parameters.
When
Again,
can
we
you start
have
getting paid? Like, when is your
3,500
paperwork and all
PSI.
that?
Once I graduate.
Once you graduate,
We're
then you
going
can
to
get the work.
use.
Mm-hmm.
Okay.
Because I cannot be in school and work
Okay.
at the same time.
And then we're going to take
as
a
soon
look
as
at
school
our
ends,
edges now.
That's it. You get it right away, or
And
So
then I
this
have 2
design, we're
months
going to
find a
have
place.
these edges, and we're going
And then you
to
gotta
move
find
across.
everything
We're going to have the
else.
default installation
So
conditions, hammer
what
drill,
if
dry
you take a
concrete,
semester off, you
no
go to
supplementary
workers,
reinforcement
what is it
again.
called?
And now let's
Worker-
move over to the
worker
anchor
visa?
plate tab.
No.
So the anchor plate
No?
tab, we're going to have a
Oh.
little bit thicker here. We're going to
Oh,
have
I'm
a
not gonna-
1-inch thickness on our base plate. And
I'm
now
not
we're going to
gonna
have
do that, but I
standoff.
don't know what will happen.
So this is something that we get a lot of calls
So you're
on,
not
and we're
gonna
going to
do it
touch
yourself?
on when to use and why to use
You
here.
can't afford to take one off.
Our application is
Because
going to be
if you take
standoff
one
with
off, you
grouting.
don't get a workers.
But we
insurance.
essentially give you 4
And then
standoff
you're
options, and the
gonna
reason why we
what
give
are
you
you
this
doing?
is because
True that.
Hilti is taking into
Yeah.
consideration the flexural
'Cause
bending
if you did get a
that the
workers visa,
fixture
then school's gonna start
can
another
be
semester
subject to
later,
when
and
you
so you
have
can't do work and
standoff.
school at the same time.
No, I need to.
So if we're
like,
using an adhesive, we could possibly use the standoff without clamping or
So if-
standoff
if
with
you were to
grouting
take a
because the
semester off,
anchor is
then
not
you have
torque
to go home.
controlled. If we're
Right, you
using a
can't be
torque
here.
controlled anchor such as a quick bolt TZ or a wedge
How
anchor,
long does a work
we'd probably
student
want to use
visa
standoff
last
with
if you're not in
clamping.
school?
So we're going to use
Oh, I have
standoff with
my-
grouting, and now you're going to
my
see what the
other
software
visa,
defaults to.
Okay.
It's going to default to this
But
grout
my
pad
school is
height.
gonna-
We're going to
once I
change
get
it to
out
2
of
inches.
school. And
But
they're
the
gonna
one
give
I
me
want to
another
focus
visa
on is
for the
rotational
others
restraint.
for example.
So the rotational restraint varies from 1
Dude,
to 2.
that sucks.
Essentially 1 meaning we are allowing the fixture to rotate.
Do you like it
2
back home? or
means
no?
we have full fixture
Where are you from?
restraint.
Wait,
So we're not allowing for that fixture to rotate. Some of you may be going, okay, how do I
Is there
calculate this?
anything
How do I
do that?
calculate
Like,
this?
there's
Well,
no
this
job?
comes from the European Technical Approval
What do your parents
Guidelines,
do?
where we're looking at flexural bending,
Like
because
this?
there is no
Or
standard in the United States to account for flexural
Wait,
bending on
what
an
it
anchor
says it.
system with the standoff application.
No, your dad,
So now
farmer.
you have an idea of
Or
where
he
that
works
calculation
in
is
a farm,
coming
he
from,
doesn't
and the
own a
report's
farm,
going
or-
to show you
Oh.
that exact calculation and all the
Here's my
parameters it's
report.
using.
We don't have animals.
So now that we have our standoff set,
Well, yeah, that's
We
why.
have-
we're going to take a look at our anchor
He
layout. So
harvests
you'll
his own,
see
right?
we don't want to leave it
And
here at our
then
4-bolt
we have-
pattern.
So like what is this?
We need to go to 8 bolts. We don't have an 8-bolt
No,
pattern
we don't know.
here, so
We
we're going to
have-
select a 9
Where are you from again?
and just
Where you from?
manipulate this anchor layout a bit. So the way we do this is we're going to go to customize layout, and now you're going to see where you can
V8.
input all of your anchor locations.
No, V.
I'm going to delete the anchor in the center.
L. No. No.
And so you'll note now we do not have an interference in the profile.
V-A-L-L-E? No, that's wrong. Like Valle, like the Valle.
Okay.
So moving over to our profiles tab,
Space?
this is where we're going to change our
It
profile to a W8 by 58. So
pretty
here we
good.
have several that are preloaded into the software.
That's why I
We're
was
going to
wondering.
take a look at
That's not what it was.
a W8 by 58 flange. You'll note when I select something, it's highlighted orange. That means it's activated. So I'm okay here.
Yes.
Everything looks good, except I want to rotate this profile. So I'm able to do that by the rotation, and if I wanted to change the eccentricity, I would be able to do so. So moving over,
really
I
close.
want to now look at
So I got,
That's like 2
our
hours.
loads tab.
No, like an hour.
So here
1 hour.
I'm going to use
1
ACI
hour.
31814,
1 hour to Brownsville. 1
and I
hour
want to
and a
do
half
seismic
to
design.
yes.
So I want you to pay attention. When I click on the seismic design button, you're going to
Where's
see
the-
several
is
of
there
the
any bad
anchors.
parts here?
I'm going to hide these so we
Like
can
bad
see what
parts?
happens. You're going to
Yeah,
see
like
several of these
dangerous.
anchors
Mm.
disappear. And we get several calls on why are these anchors disappearing?
The word
Well,
mata
we're
is
about
right
to
here,
cover
so I
this. So I
think it's bad.
click seismic design, and you'll see that everything has disappeared except our 2 flagship adhesive
Here.
systems, as well as our threaded rod and rebar, our threaded rod system. And so you'll see what happens is
Here, that's my
Oh,
favorite.
hey,
we're
look.
assuming,
This is my
or we're
favorite.
defaulting to that ductile provision
that's it.
for seismic
This is my
design. So it defaults to the provision where we're
Yeah,
trying
I
to
think that's
design the
it.
anchor connection
When I leave-
to yield in a ductile manner. So it filters out all of the anchors
Your house is
that
right
do
here.
not
Over
meet
here.
the ductile requirement by definition. This is very
No,
important. So
actually,
ACI has that definition on what that ductile requirement is. So it
This-
defaults to this, and
The
that's why
Mexico
it's
one doesn't let
filtering
me
those out.
Look
So the way we change this is we simply click on,
Here,
where.
and we click on this,
Yes,
this
I see
icon,
my
and we're going
house.
to have the 4 seismic design options available.
Oh.
So it defaults to, we're trying to design the connection where the
Yeah.
anchors will yield in a ductile manner. The another option we have is we can
Yeah.
design the base plate to yield in a ductile manner, assuming all other failure modes are brittle. And then we have provision C, which is going to be this crushing of the fixture, so a brittle fixture failure mode. And then option D is going to assume all of our failure modes will be brittle, and so because they are brittle, we're going to apply
Here's
an omega naught
It's
overstrength
here.
factor to the earthquake components of that
Here.
factored load that we've
That's my
decided
house.
is going to
It's
be on the
huge.
anchor system.
and I have a pool
So
in
this
there.
provision D is what we're going to use.
not right here, but you have it now, right?
Uh-huh.
You'll note when I
think
click
that's-
this,
that's all.
we're getting a note on the screen. Why
It's
are
a
we
big
getting a note
house.
on the screen?
It
Because
looks
we
big.
want to make sure that you have taken
like a
into
mansion.
consideration the omega naught
It's a
factor
mansion.
found
You
in
live in a
ASCE.
mansion.
No.
Okay, so when I input these loads, I'm already going to assume that I've
Look, dude.
input the omega
25
naught
miles? Your
factor
house is
into the
25
loads that I'm
miles?
going to use.
That's
But
made
if
it.
you hadn't, you could click yes,
50
and then
feet.
input your factored loads, so revise your factored loads to consider that omega naught factor now. So we're just making sure that we've accounted for these loading conditions when we select this option, because 3 out
Yeah,
of 4 of the
50 feet.
failure modes in tension do not have.
Your house is
the omega naught.
60 feet this way.
So we're going to select the same in shear. It's going to prompt us
About
again. We're
80
going to
feet
select
this
no. And now we're going to
That's pretty big.
begin inputting parameters
And how
into
many
the design.
stories? It looks like it's like 2 stories. Yeah. There's a story right here, second story. Like that.
So here I'm going to change my anchor
And some here.
spacing first. It's going to be symmetrical anchor spacing.
No street. You want to see where I live? All the places I've lived.
Okay.
I've
And the
moved
next
like
thing I'm
5
going to change
times.
is our base plate.
Here in the valley.
Base
yeah.
plate will be 20 by 20,
Like
so
every
we're okay.
year of high school, we moved.
Really?
Because my mom couldn't afford the place, so she's like, okay, I
Now
move.
we're going to
So
work
every
on our
year
edges.
we move. It sucked in high school at every year moving. I was in the same high school,
Oh,
but
okay.
I had to move houses, and I had the truck. I was the only one with the trucks. I did everything.
So let's say you're doing a project. You're in the United
see my
States, but
house.
you have a
The
project
first house I
elsewhere
lived
that you're
in,
designing for,
all
and
the
it's
way
using
until I was
different
like 15 years
units.
old was
Nice function of the feature of the software is going ahead and inputting a different unit. So we can input that different unit, and the software is going to calculate that accordingly based on the default units that we have in the system.
daffodil.
We can do the same thing with our loads. So we can input a kilonewton load in lieu of a load that's in pounds. So that's a nice feature that the software has.
I think it's
Okay, so
this
we've
one.
got almost all of our geometries input. We're going to have a 36-inch slab.
Yeah, this is
I'm
my
going to
friend's
zoom
house.
out
And he has a pool.
so we can see what's going on. And now I'm going to input that seismic moment that we talked about. This one's going to be 362,000 inch-pounds. We're going to hit enter, and now you're going to see, boom, those calculations are loading on the right side of the screen and telling us,
This is my old house.
as we're doing
People
this,
that's not our car. Somebody else.
what our
lives in it.
capacities are.
Let's see if I can move a little forward. Did you know
Okay.
you can tap and hold to move faster?
So that's it for the loads, and you'll see
Oh my God.
our utilization is way over capacity. So what we need to do is change our
That's a punch.
diameter that we
That's a nice
have,
house. I like
and
it.
our base plate's going to be set for 7/8. So the way we change our diameter is going to be selecting this
Nice
anchor
house.
filter at the
A lot of
bottom,
nice plants.
and we're going to
Love
look
that.
at a threaded rod 7/8. And now it's accounted for this in the design. So I'm going to take a look at what we have.
Ah,
Actually inputted too large of a load.
a lot of plants. Oh, it's just,
Okay. And so what the software is doing now is it's doing those calculations as we update it. And now we're going to see what we're
that
using.
was like
So
from kid all the
we
way till the
have,
freshman.
with the
year.
adhesive option, we have the flexibility
And
of
then
using a
that's it.
variable embedment depth.
The next
Okay, and
place
so
I moved,
it's going to default to optimized,
Same name?
which is trying to drive that utilization as close to 100% as possible. But
next
if we
place I
wanted to
moved
use a
to
custom
was-
embedment depth up to 20 bar diameters, because that's a limitation in ACI anchoring to concrete provisions, we can do that by selecting the user selected embedment depth. But because we are using the 7/8 diameter element, our limitation is going to be 17.5 inches.
Oh, wow.
Okay, so we've done the calculation. I want to see, are there any other anchorages that are going to be suitable for this application? So something that I can do is I am able to click on this calculation tab and calculate all of the anchors in the portfolio that I filtered out,
Pearl.
or that I filtered in by filtering others out. So you'll see
Right
here that the one I selected does not work, but there are some other ones that do. So I want to look into using RE500V3, that true epoxy adhesive, and I want to use the 7/8 B7, which is that high strength threaded rod. So to make that change in the design, all I have to do is go ahead and click on the one that I want that's fully highlighted green across the row,
Why?
and it's going to now
Because
input that and use that for the design. So this is a nice feature where if a customer has something else on site and they want to see how that works, you're able to just make the change in the software without going back to the full calculation. So it's something that's very nice feature that you can use when you're doing this design.
There's somebody at the door. Oh, no, it's a plant.
So now I want to go to the solution tab, and we're going to run a design report and take a look at this one, because we do have seismic design. So we're going to have our project laid out. I'm going to save the report. Yes.
Next place.
Now we're going to take a look
Not
at the
too far
design
from
report.
here. This is my baseball field.
Okay, so again, when we have this design report, we have all of our input data that's showing up. So we have the adhesive that's being used, we have the material of the anchor element, the provisions that we're using in ACI, we do have the grout, and it's showing us, let me zoom in,
like a mile and
what
a
we're
half
considering for full
I
restraint,
do a big square on the whole school,
as well as the epoxy,
and then I go
and
back
our
to
other
baseball field.
conditions.
I have some friends that went to that school.
Yeah.
Maybe you know them.
Now, something to note we do
They're
get questions
here,
on
my
is
age,
when
our
we
age.
input this overstrength provision or this provision D in
I
seismic
know them.
You
design,
know them?
They're
the software is not
dentist
going to
people.
tell us
Yes,
what
they do.
omega
And
naught
they have a
factor
boy.
we've used.
Yeah.
So you may be familiar. It's probably
How do you know that?
2.5 or 2,
Just-
depending on what your application
I want
is.
to be a dentist.
It's not going to tell you that.
You
All
did?
it's saying is the
Really?
user
I was
selected the
like,
overstrength
or like a
provision,
year
so the
ago,
user
like
should
that.
have
They're
inputted
really cool.
that omega naught
Yeah,
factor
like
into
that.
their factored design load, or their factored service loads.
Oh, right here, edit
So now we touched on, in the first example, what the summaries are, how that's laid out, but I want to focus on the bond strength for seismic provisions. So this way you can know that your seismic design is being calculated accordingly. So when we're doing a bond strength calculation, for example, we have certain seismic parameters that will appear when we're having to do this calculation. So I want to point you towards the variables portion, and I'm going to move my mouse to the alpha and seismic. So that alpha factor, which is very specific to the product that we've selected, has been taken into consideration. So you'll see that, yes, we are taking it into consideration in this check. In addition to moving down to the results section, we do have an additional seismic fee factor that's being applied to the design. So this tells you as the design engineer that, okay, this software is using these bond strength provisions from ACI as the basis of the calculation, and it's using these variables, it's taking this into consideration from the calculation side of things, and here's the result of the design bond strength capacity that we have here at the bottom of the screen. So again, the software is very well laid out. We're able to see transparent what the software is doing, what it's taking into consideration when we're walking through the design. So I want to bring you back to the software. Our utilization looks good. Our fastening meets the design criteria because our design capacity is greater than the factored loads that our application is seeing, and so we want to specify this. So how do we specify, what is the specification text that we need to use? Well, the software has a great feature in the solution tab where we can click on that specification text, and so that spec is already there, and we can directly copy and paste that into our drawing for use in a detail. In addition to, for the general notes side of things within your details, we're going to have a general notes function, which is highly specific to Hilti. And so there's no guesswork in what these general notes should be. You can come to Profis Anchor and you can copy and paste this information directly into those drawings, so you can use that information for your project designs.
The last one's not really my house.
So that is the end of the software. Actually, let me backtrack. There's one more thing I want to cover with the adhesive system, and that is sustained loading. So with sustained loading, we input, so when we have an adhesive, we've got to do an additional sustained loading check that's present in ACI. So the way the software will account for this check is we go down to the table here, and we can input what these sustained loads are in the tension or what sustained loads that we have for that moment. So it's very important that we do input those sustained loads whenever we have anchors in tension or that are constantly in tension per ACI. So it's going to make that additional sustained loading check. So that's the end of our software walkthrough. I'm going to pass it back to Brian, who's going to finish up the presentation. Thank you very much for your attention.
But it seems boring. This is where I used to go work out a lot of times. They burned. They had a big fire. So.
Really?
All right, thank you, Morgan, for giving us that great walkthrough of the Profis Anchor software. One thing I wanted to point out for everybody who has been following
faded away already.
On the left, you're going to see an example of a hand calculation.
Nice.
On the right, you're going to see the output of Profis Anchor. As you can see, the Profis Anchor output will give you a nice uniform look. So that way, when your analysis is going through a plan check, everything is laid out in a nice, easy-to-read format, and you don't have to struggle with looking through someone else's work, trying to see where they made their assumptions, where they put in their values. So again, just another great reason why the Profis Anchor software, as Morgan stated, will provide everything for you in a nice format that's easy to follow along.
And over here, this whole part.
So with that, I want to quickly summarize the presentation. We do have a lot of questions, so I'm going to go a little bit quicker through this part so that we can try to answer some of these questions.
They have a big indoor pool too.
Again, we look at the different ways which you, the designer, can evaluate an anchor system. And most of you did say you are currently using